So I asked you to attempt these three. What? Okay. All right, so I didn't ask you to attempt these three. Let's talk about them. This very first one right here. You would know what to do if that x had something added or subtracted to it, yes? And you would know what to do if that x had something, added or subtracted to it afterwards, yes? So, since neither of those things happened, I know that the vertex of this parabola must still be right there, correct? Now, what then does that mean? What then does that mean? I don't know. So what do? We do an experiment, the way we should always do something. Take knowledge that we already have and see if we can use it to find out new knowledge. So, whenever we are graphing, we can do one of these. Now, we know it's going to be at 0, 0. So we should pick some x's that are on both sides of 0. Now, the ones I like to choose, I shouldn't have said 0, on both sides of the vertex. Now, since this vertex is at 0, we're going to take -2, -1, 0, 1, and 2. Yes? And then we're going to put them in here. What is -2 squared? 4. What is 4 times 2? 8. Excellent. What is -1 squared? 1. What is 1 times 2? 2. Excellent. What is 0 squared? Times 2? 0. What is 1 squared? 1 times 2? 2. What is 2 squared? 4 times 2? 8. And I draw my parabola. 0, 0. Over 1, up 2. Interesting. No. See, this is math class. Close the door. Close the door and sit down. And then, of course, left 1 and up 2. -1, 2. Right 2, how far up? 8. 2, 8. And what will this one be? -2, 8. Now, if that was not there, how far up would I have gone when I went over 1? 1, but I went up 2. How far up would I have gone when I went over 2? 4, but I went up 8. So what does this number as a coefficient do? What does it do? Multiplies what? It multiplies the x, but what does it do to my parabola? It makes it stretch vertically by a factor of what? 2. What if this was 3x? Then I went over 1, how far up would I go? 3. When I went over 2, how far up would I go? 12. What if it was 10? When I went over 1, how far up would I go? 10. When I went over 2, how far up would I go? 40. When I went over 3, how far up would I go? 90. Does everybody understand? Now, take that knowledge and apply it over here. When it was 2, we went up twice as much. So now it's a half. So what will I go up? No. 2 is twice as much. Half is half as much. Is my vertex here 0, 0? No, of course not. What is it? -4. So I slide down 1, 2, 3, 4. And normally I would go to the right 1 and up 1, correct? Yeah. But that is not the case in this one, is it? How far up will I go? A half. Now that's a bit of a pain in the ass on a hand-drawn graph, isn't it? Yeah. When I go over 2, how far up should I normally go? 4. But how far up am I going to go on this parabola? 2. Half of 4. So when I go over 2, which will make my x value 2, I will go up how far? 2, which will make my y value negative 2. Yes? And what will it be over here?
2 and
negative 2, negative 2. When I go over 4, how far up should I go? 16. But it's halved. So how far up will I go? 8. So if I go over here to 4, I'm going to be up here at positive 4. And what will I be over here? Negative 4. 4. Now please look. When it's a fraction, what happens to my parabola? It widens this way. When it's a whole number, what happens to my parabola? It shrinks this way because it stretches this way. Does everybody understand? So now you've been exposed to everything that can happen to a parabola. You've been exposed to how the vertex moves on the x-axis. You've been exposed to how a vertex moves on the y-axis. You've been exposed to stretching or widening the parabola. And you've been exposed to a positive and a negative number. What do you see in this last one? Starts with an E, ends with a G, and has very thin in the middle of it. Everything. So, if nothing was happening here, it was y equaled x squared, we could graph it, right? It would look like this. Woohoo! Yeah? But it is not that, is it? This vertex is moving. So the first thing I need is a vertex, don't I? So I know where to start. Where is this vertex going to move? Talk to your neighbor if you do not remember, or turn the page over, back one, and see. The vertex is going to move in 2 directions. Which 2? You've got this on the page right before. We did this yesterday, people. I know 24 hours is a long time in your lives. Yeah, it will do that, Anna, but I need to find the vertex first, so I know from the point I'm going to start. Where will it move? Damaris? It will move 2 in which direction on which axis? It will move 2 on the x-axis. In which direction? The positive direction. So it will move out 1, 2. Where else will it move?
It's 6 on the y-axis.
6. 1, 2, 3, 4, 5, 6. So it will be up there, yes? Yeah. Now, since I have that point of 2, 6, I can now graph, can't I? The first point will be 1 to the right and 1 to the left of my vertex. Correct? So this point over here will have an x coordinate of what? Of 3. And this point over here will have an x coordinate of what? 1. Excellent. When I move a regular parabola 1 to the right, how far up should I go? 1. But I am not going up because there's a negative sign. So where am I going? Down. And I am not going up 1. What am I going? 3. So I'm going to move over here to 3, and I'm going to go down 3. So what will my y value be? 3, 3. And automatically, what will be my reflected y value? 1, 3. When I go over 2, I should go down how far? Yeah, you're jumping the gun. I should go down 4, but I'm going down 3 times 4. So I will go over to 4, and I will go down 12. 6 will take me to 0, and 6 more will take me to 4, negative 6. And then automatically, what's over here? 0, negative 6. And there is my parabola. Is everybody good? Now, it took a whole page to show you all that stuff. When I asked you to flip back a page, very few of you could find what was happening here because there's so much information on that last page, yes? So here, we are going to put it all in one place for you. If I were you, I would put a big old Mrs. Bad Crumble cloud around this. Because this is what you're going to need for the next entire unit. Let's put the stuff in of which we know. There is my form. Talk to me about this stuff. Let's start with what form is a parabola naturally in? What should it look like? Y equals x squared. And we can all graph that, yes? That starts at 0, 0. It goes over 1, up 1, over 2, up 4, over 3, up 9, over 4, up, over 5, up 25, and so on and so on and so on, yes? For how long?
Forever.
Ever. When it goes left, it will go up the same distances. And that line right in the middle is the axis of symmetry, right? That's a regular parabola. This has adjustments to it. There is this adjustment. There is this adjustment. That's not the adjustment, you idiot. This adjustment. And this adjustment, correct? The first adjustment, what does the A do? We just did 2 of these. What did the A do? Yep. So which does it change, Damaris? Does it change my input or my output? It changes my output, yes? A multiplies the output. Now, is the output an X or a Y value? Ooh, it is the Y value. Multiplies the output. What does that mean in plain English? Every Y coordinate from the original parabola, which is what? Y equals x squared. I'm going to highlight that in yellow. Every Y coordinate from there is multiplied. Forgot an E, that's multiplied. Multiplied by A. What is the result? Either the parabola multiplied by A. I'm going to highlight that green because I used green. Either, if it is a whole number, your parabola gets skinny because it stretches this way. If it is a fraction, your parabola gets wider because it stretches, it shrinks up and down. Is everybody cool? Yeah? All right. The next one is P, which I have highlighted in pink. B, which is pink. What does P do?
The x-axis.
P adjusts our input, which is what?
X-axis.
The X value. What does it actually do? It moves the vertex in the opposite direction of the sign. And we have already seen this, haven't we, when we were factoring. X minus 4 equals 0. So the answer is x equals 4. Yes? We've already got a time in this math class where the sign we see in actuality in the answer is the opposite. Right? So what are the results of this? If it is x plus p, the vertex moves left. If it is x minus p, the vertex moves right. Everybody good? Good? And the last one is Q. Q adjusts the y coordinate of the vertex in the same direction as the sign. What does that mean? If it is plus Q, your vertex moves up. If it is minus Q, your vertex moves down. Everything in one place. Is everybody cool? Now, let me ask you this. When I give you this equation, could we graph that using a table of values? Could I go x, y, put x in, do all the math, and get a y value? Yes. How long would it take? A long time. How long will it take to do it with the vertex rules we just learned? Now, when I say we learned them, did I tell you what they were? Or did we experiment and find them all? We experimented and found them all, yes? So this is not a simple matter of, Myers said to do it this way, let's do it this way. We've already figured it out. So step 1, the location of the vertex. What part of this equation finds me the vertex? The x, the y, the a, the p, or the q? Q is half of the vertex. What's the rest of the vertex? P. So I need to be looking at P and Q. I read my list. I see that P moves the vertex opposite of the sign. So what is my P value right there? 4. So my vertex is at negative 4. My Q value moves the vertex in the same direction of the sign. My Q value is positive 1, yes? Yeah. So what then is my Y value of my vertex? Positive 1. So my vertex equals negative 4, 1. Let's draw it. Where is negative 4, 1? Go to the left 4, 1, 2, 3, 4, and go up 1. Is everybody happy with that? Now, I am going to label it because this isn't real graph paper, yes? If it was real graph paper, we could all see it was at negative 4, 1. So I'm going to go ahead and label it negative 4, 1. Now, what's the next thing I ask? The equation of the axis of symmetry. The axis of symmetry is, of course, the vertical line that goes right through the parabola, yes? So what is it? X equals what? Negative 4. Agreed? Okay. The range of the function. So those are the y values. Is this parabola going to open up or down? Down. What tells you that? The negative sign in front of A, correct? So since this is going to go down, y must be greater than or less than my vertex. Less than. Will it actually hit my vertex? Yes. So it is less than or equal to 1. Everybody understand? So, since it's going to go downwards and all my y's are less than 1, do I have a maximum or a minimum? I have 2 maximums and 2 minimums. Somebody break the tie. Look back if you need to, because I've already explained this to you. I have a maximum, don't I? Because this parabola will never go higher than 1, will it? Because it opens downwards and it peaks at the vertex. So what do I have? I have a maximum at x equals -4. A max of 1 at x equals -4. Is everybody cool to there? Now the last thing I want you to do is graph this, correct? If it were a regular parabola, I would go 1 to the right and up 1, correct? Is this a regular parabola? No, there are 2 things different here. What is the first thing that is different? It's going down. It's negative. So I'm going to go to the right and down instead of the right and up. How far am I going to go down? Normally, I would go right 1, down 1. How far am I going down in this one? It's the only letter we haven't talked about, and you've got notes on it, literally 3 inches from where we are working. He waited patiently. On a normal parabola, we go over 1, down 1. What is different? We're going to go down 3. So, when I go over to -3, I should go down 3, which is what point? -3, -2. What is automatically over here? -5 and -2. Because they're reflected, yes? When I go over 2, how far down should I go? Normally. 4. How far down am I going to go in this question? 12. So I'm going to go over 2, which will take me to -2, and down 12, which is -2, -11. What is automatically over here? -6, -11. Please notice, they're 4 apart. They're 2 apart. They're 4 apart. How far apart will the next ones be? Could it be 6? Could be 8? You don't know the pattern yet, do you? Because it's changed because of the 3, right? That 3 is going to change our parabola, yes? So you don't know how far apart they're going to be unless we did one more. If we did one more, could we then make a prediction for how this would look all the way down? Let's do one more. When I go over 3, I should go down how far? 9, but I'm going to go down 27. So I'm going to go over 3 to -1, and I'm going to drop 27 to -26, yes? And what's automatically over here? -7 and -26. Now, how far apart am I? 7 to 1. 6. Now can we make a prediction? The next points will be how far apart? 8. Then what? Then what?
12.
Then what?
14.
Forever and ever and ever. Everybody understand? And then we would make our parabola. Ah! We would make our parabola. It's a skinny one. Because this distance has been stretched. Gouda? Gouda. There's 4 of these. That is all I want to do today. So we're going to go through these 4, and then I'm going to make you practice some on your own. I'm going to do 2, then I'm going to start asking you about 3. What is my vertex here? X has nothing attached to it. So is my vertex moving? No, it is still at 0. Is it moving up or down? Yes, it is dropping 11. So I'm at -11, 0. And I'm going to stop there and make sure everybody understands why. Does everybody understand why my vertex is 0, negative 11? There is nothing that is affecting x plus or minus, and the q is negative 11. Is everybody cool? So the axis of symmetry is x equals 0. The range, is this parabola going to be happy or sad? Happy. It's going to open up. So the range y must be greater than or equal to my vertex, which is negative 11. Is that a max or a min? It's a min of negative 11 at x equals 0. Now I'm going to graph it. Normally I should go over 1 and up 1, but I'm going to be going over 1 and up 4 to 1, negative 7. Automatically I know I'm 2 over here to negative 1, negative 7. Agreed? Next one is going to be at 2, should be up 4, but it's not going to be up 4. It's going to be up 16. Oops, that's too high. 2, 5. Automatically, I know I stay at 5 and I go over here 4 to negative 2, 5. And there's my parabola. Everybody good? All right, you've seen it twice now. Now, I recommend on the side here writing down everything I need to know from this. So from this, I know my vertex has to move which direction? It says negative 3, so it really moves right 3 for the x value. It says plus 5, so it really moves up 5. It's negative, so it's a downward-facing parabola. And it's a 1, so is there any stretch? No. So there's no stretch. Once I see that it's a down parabola, I know my range, y's have to be less than or equal to, and I have a max. That's everything I know, right? So let's do that. What's the vertex? 3, 5. Okay, axis of symmetry. X equals 3. So now all my numbers are going to be 1 away from 3, 2 away from 3, 4 away from 3, 4, then what? 6, then what? Then what? And then I'm too short to make it obvious, because if I stretch anymore, I'll look stupid. Not like I don't look stupid now, but I already look like a tool. But that's okay. It's kind of a Y pose, not a T pose. The range of the function, y must be less than or equal to what?
5,
5. And is it a max or a min?
A max.
Max of what?
Max.
5 at what value?
At 3 value.
X equals 3. Now let's graph it. Where's the vertex? Right, 3 up 5. And I label it. 3, 5. Now let's put in some points. 1 to the right, and down how far? 1. So that is 4, 4. What's automatically over here? 2, 4. 2 to the right. Then how far down? 4. So that's going to be 5, 1. What's automatically over here? Oops, that's 0. Sorry. 1, 1. And that's enough. Everybody cool? Everybody good? Okay. What do you know about number 4? Is the vertex moving? What directions? To the left, how far? And? Down 5. So what's my vertex? Negative 2, negative 5. Awesome. What's my axis of symmetry? Look. Negative 2. Is it a positive or a negative parabola?
A negative parabola.
So it's that. So do I have my range is y greater than or less than in that one? Less than or equal to. And do I have a min or a max?
Max.
I have a max. What else do I know? Will it stretch? How far? Is it going to get taller or wider?
Wider.
Wider, because it is going to shrink vertically. So all of my y's are times 1/2. Right? So let's do this. My range, y is less than or equal to what?
Negative 5.
-5. Max or a min?
A max.
Max. Of? At?
Negative x equals
-2. Graphic. -2, -5. Yes? Now, when I am graphing, should I go over 1 or should I go over 2 to do my first point? I should go over 2. Why? Because it's being divided by half. So going over 2 makes it easy to go down 1, yes? So I'm going to go over 2 to 0, and then where? Down 1 to -6. Now, since I've gone 2 away, how far do I got to go this way? 4, because we skipped the 1 step, didn't we? So we're going to go over here 4. So that's -4, -6, yes? Should I go over 3? No, because 3 is yucky. If I go over 4, I should go down how far? 16, but, Derek, it's 8 because we've cut it in half. So if I go over 4 out here to +2, I'm going to go down 8 to what? To -13. And what's automatically over here? -6, -13. And then it stretches out this way. Is everybody good? All right. All I want you to do for the rest of today, which is 31 minutes, you're going to graph 1, 2, 3, 4, 5, 6, 7, 8 parabolas. Now, please notice I've given you actual graph paper, but I've only given you one graph, right? Yeah. Do these both on the same graph. It'll be okay. Trust me. The vertexes are far enough apart, you'll be able to do it. For your own benefit, you may want to do this one you may want to use colors. You may want to do, this one is little dots, and this one's a straight line. I don't know, whatever you want. Okay? Everybody understand? Did I give you only one? Yeah, okay. Everybody cool? What happened? Is there a screw up? Everybody's okay?
Is it only 98 and 99?
Yeah, just 98 and 99. Yep.